Hello, my name is Mr. Kelvin from Educare Institute. Welcome again in our lecture session, and today we have presentation based on physics, and we are proceeding with our amazing topic, which is geophysics. In geophysics, we already discussed on the previous lectures about the structure and the composition of the Earth, but also we look about the structure and the composition of the atmosphere. And we are proceeding with our subtopic, which is earthquake and volcanoes. But we already look on the part of volcanoes, and now we are proceeding with our part, which is earthquake. On the earthquake, we already look on the meaning, we already look about seismic waves, and we already look about the magnitude of the earthquake. And now, in our today's session, we will look about the intensity of the earthquake. Let's move together. Let's look about the intensity or earthquake intensity. When we say the intensity of an earthquake is a measure of its strength based on the changes it causes to the landscape. So when we measure the intensity, we look about the strength, or it based on the strength on the changes which the earthquake make or made to the landscape or caused to the landscape. That is how we look about the intensity of the earthquake. But also we say the intensity of an earthquake is usually measured on the modified Mercalli scale. So the intensity of the earthquake is usually measured on the modified Mercalli scale. And we say that the scale is calibrated from 1 to 12. On this scale, level 1 is a minor tremor that causes no damage, where the level 12 causes total devastation. Kwamba hii scale imebi calibrated kutoka 1 12, kutoka 1 hadi 12, na tunasema kwamba hii scale ikiwa level 1, maana yake ni kwamba hii ni minor tremor, means kwamba ile earthquake haijasababisha madhara, has caused no damage. Lakini ikiwa level 12, ile Mercalli scale, modified Mercalli scale, ikiwa level 12, tunasema hapo imesababisha total damage, means total devastation. Consider the description below, which shows the kind of intensity and its intensity effect. Kwamba description inayofuata tutaangalia intensity kutoka 1 mpaka 12 na effect zinazotokea. Welcome to look those intensity and their effect. So starting with scale 1, scale number 1. Katika intensity, which is located as intensity number 1, we say effect of intensity number 1 not felt except by very few people under especially favorable condition. That is the effect. But number 2, we say that felt only by a few people at rest, especially on upper floor of building. Kwamba hii hapa, hii effect namba 2, kwamba it being felt, kwamba watu wanaoipata ni few people, yani watu wachache ambao wako at rest, na especially wale wanao katika upper floor of building, wanaokuwa katika floor za juu za majengo, wana experience hii intensity namba 2. But the third intensity, we say its effect is that felt quiet, noticeably by person indoors, especially on the upper floor of the building. So this is felt quiet. It is noticeable by people who are indoor, and especially for those who are in upper floors of the building. But number 4, we say felt indoors by many, outdoors by few during the day. So this during the day, it is felt by most people who are indoors, by many outdoors, by few during the day. Number 5, we say felt nearly by everyone. Many are awakened. Some dishes, windows broken, unstable object overturned. Kwamba hii hapo ni intensity number 5, tunasema kwamba hii kila mtu anaipata. Kwamba kila mtu experience hii effect number 5 au intensity number 5, ambapo many of people are weakened. Na tunasema vitu kama vile dishes, windows zinakuwa zina broken, na ikikuta object ambayo ni unstable, kwa mfano ikikutana na nyumba ambayo ni unstable, yani haina uimara, zinakuwa overturned, zinaweza zikadondoka na vitu kama hivyo. So that is the effect number 5 or intensity number 5. Intensity number 6, we say that felt by everyone, many are frightened, some if furniture moved. Kwamba hii pia inamkuta kila mtu, na yenyewe sasa baada ya kumkuta kila mtu, many are frightened, lakini pia ikikutana na hizi buildings, majengo yale makubwa hivi, furniture kubwa zinakuwa be moved. That is effect number 6. But effect number 5, we say that, or intensity number 7, we say that damage negligible in of good design and construction, slight to moderate damage in the well. Beauty ordinary structures, considerable damage in poorly built or bad designed structures, some chimney are broken. Kwamba hii hapa effect number 7 inakuwa ina affect zile building ambazo ziko poorly designed, aziko strongly built, they are badly designed structure, but also some chimney are still broken due to that effect or intensity number 7. Now let's look effect number 8. Tunasema kwamba damage slight in specially designed structure, consider damage ordinary substantial building with partial collapse, damage great in poorly built structure, fall of chimney, factory stocks, columns, monuments and walls, if furniture are overturned. That is the effect number 9. Effect number 9 tunasema damage considerably in special designed structure, well designed frame structures thrown out of the plan, damage great substantial buildings with partial collapse, buildings shifted off foundations. That is effect number 9. But effect number 10, we say that some wealthy building wooden structures destroyed. Kwamba baadhi ya kuta ambazo zinakuwa be destroyed. Most mansur and frame structures destroyed with foundations. Kwamba most of the hizi frames, our mansur, their frame structures, they are being destroyed. For example, hizi rail bends vinakuwa zinavunjika. Effect number 11 au intensity ya earthquake number 11, we say that few, if any structures, mansur, remain standing, bridges destroyed, rails bent greater. Kwamba hii hapa inasababisha hizi madaraja yavunjike, railway zile zinda gently. But the last intensity of the earthquake, ambayo ni scale number 12, tunasema kwamba total damage lines of sight and level are distorted, object is thrown into the air. Hii ni hatari zaidi, kwamba hii ni intensity ambayo ni hatari zaidi, kwamba kila kitu kinakuwa total damaged. Building, object, peoples, all of them, they are damaged, they are totally damaged, and objects are thrown into the air. That is effect number 12 au number 12. And this is how the scale of the intensity is expressed. Now, something to note, we say that earthquake can only have one magnitude, but its intensity reduces as the seismic waves spread out from the epicenter. Kwamba tunasema kwamba hivi earthquake inaweza ikawa na only one magnitude, lakini intensity inakuwa inabadilika kulingana na zile seismic waves jinsi zinavyokuwa zinatokea. That is how the earthquake is. Kwamba magnitude inaweza ikawa ni moja, lakini zile intensity zikawa ni tofauti kulingana na jinsi zile seismic waves zinavyokuwa zina spread out. Now let's look about the device called seismograph. We say that seismography is an instrument used to record ground movement caused by the earthquake. So the device which you record the ground movement which is being caused by the earthquake, hicho kifaa tunakiita seismography. As you can see in the diagram, this is the structure of the seismography. There is horizontal and there is vertical. There is knife edge pivot, there is mass. There is recording pen, this one, recording pen. There is recording drum. There is a threaded axle. There is clock. Also there is mass, there is a spring. That is the structure of the seismography. So now let's look the mechanism how the seismograph do its work. How the seismograph records the movement of the ground which have been caused by the earthquake. We say that it consists of pendulum bob which can oscillate even in a small earthquake. Kwamba hii seismograph contain a small consistive pendulum bob ambayo inaweza ika-oscillate even if there is a small earthquake intensity and magnitude. But also we say it measures the ground oscillation by recording the relative motion between the pendulum and the ground. Kwamba inapima ground oscillation kwa kufanya comparison of the relative motion kati ya pendulum pamoja na the ground. Kwamba wafanya comparison ya relative motion kati ya ground pamoja na pendulum na kuwa inafanya recording of the na kuwa na measure the ground movement or ground oscillation. But also we say in order to measure the ground motion, the seismograph must remain steady when the ground moves. So in order to measure the ground motion, seismograph it should remain steady. For it to measure, it should remain steady when the ground moves, for measuring the ground motion. But also we say the time of initiation of ground oscillations is recorded and marked and are included on the graph every minutes and hours on the seismograph papers. That is how. So that is how seismograph works. Now let's look at the types of the pendulum. Aina za pendulum. We say various types of pendulum include simple pendulum. We say that simple pendulum if mass is suspended by a wire or rod from a fixed point. But also we say inverted pendulum as a heavy mass fixed to the upper end of the vertical rod pointed at its lower end. But also we say there is horizontal pendulum as a rod with a mass on its end which is suspended at 2 points so that it swings on horizontal plane. Those are 3 types of pendulum based on the device which we call seismography. So, recording the pendulum motion. How to record the pendulum motion? We say that the recording of the motion of the pendulum can be done in various ways. The first way include mechanical method, optical method, and the last one is electronic method. We say that mechanical method, sheet of smoked paper is wrapped around a rotating drum and mounted to move with the earth. A moving pen connected to the pendulum presses lightly on the paper. As time passes, the drum rotates so that the recorded lines are not superimposed on each other. But also we say deflection of the pendulum is commonly magnified mechanically by a single or double multiplied level so that the graph is easier to see. That is how you can measure the motion of the pendulum by using the mechanical method. So something to note, we say that this method is simple and economical. But also we say that seismography must have an even mass to overcome the friction between the pen and the paper. So for seismography to overcome the friction between the paper and the pen, it must have a large mass. But also we say mechanical seismography weigh on ton or more. So mechanical seismography weight lazima ianzie 1 ton na kuendelea. That is. So let's see another method of measuring the pendulum motion by using optical method. We say that the optical method still uses a pendulum motion to record the ground movement. Kwamba optical method, still uses the pendulum motion to record the ground movement. And you say, however, to overcome friction, mirrors are used to reflect the light onto photosensitive papers wrapped on a drum. So for seismography to overcome the presence of the friction, we say that there should be the mirrors which reflect the light toward the drum.